Welcome back to the Decode Podcast. We're
Thank you.
here at IPC Apex 2025 with our good friend David K. And
Go ahead and try to pronounce it. I want to hear him say it.
I was going to say, if you don't know how to pronounce my
Kruidhof.
name, that's... Oh, you got it.
All right.
That's a lot less fun.
I know him as David K, but he had to upstage us. He's looking pretty
Yeah.
snazzy here.
Yeah.
And,
You look like a salesman, honestly.
Yeah,
Well, it's the German way.
it's the German
Dress
way.
up for a show.
You're German?
Treat it with respect. No, but the company is.
So David is our network X-ray guru.
Yeah.
And a couple of us had the opportunity to go visit him at his lab.
The important ones.
We're
The
really going to
important
bring this
ones.
up
Yeah,
on...
the important
And
ones, yeah.
got to see
I think everyone was there, right?
everybody who mattered.
Everybody that mattered.
Yeah.
And it was a great time. I honestly
Oh,
can't
the
think of...
tacos.
I can't think
Oh,
of a single
tacos were
way
good.
it would have been
Yeah.
improved, right? Like,
Yeah.
I don't know.
what could have
That's a great
changed
question.
that would have
Yeah.
even made an impact?
I don't know, just the greatest guy to ever film stuff being there. Maybe that.
So, X-ray technology.
Yeah.
What kind of challenges are you encountering within your customer base or prospective customers? What pain do people need to solve that X-ray technology can heal?
Yeah, I mean, the main thing with X-ray is you can see what you can't, right? So optically, AOI is generally a lot less expensive. You put it on every SMT line, but you can't see those bottom terminating components. You can't see the solder joint. You can't see the thermal pad. So what's your voiding look like?
Or barrel fill.
Yeah, unless you want to like destroy it, destructively test it, then sure. But now it's destroyed. So what's the point?
And the prevalence of bottom terminated components in modern circuit assemblies
It's only
is
increasing.
Yeah.
just going
Yeah.
more and more that
Yeah.
way.
I was reading something about just passive components. The pads that are being recommended are like the size of the component, not even larger. So there's not even going to be a fillet. It's even just a resistor is going to have bottom terminations. It's like,
Oh, wow.
I don't know when that's going to actually come, but
Wow.
that's insane.
That'll get challenging.
I think we've
Yeah.
started to see that a bit with certain components where there's no metallization along the perimeter of the pad.
Well, there's
just
a
on
lot
the
of
bottom,
diodes
right?
like that. There's
Yeah.
a lot
Yeah.
of those bottom terminated little diodes. Trying to think of what package it actually is now. I can't
Or
think of
LEDs.
it,
I mean, Sean had to build ones that
Yeah.
had LEDs that were that
Yeah.
nature. You can't inspect the solder
You know
joint.
what's funny? I can see the part in my head. It was a black cap, and it had all bottom terminated on it. And I can
Yeah.
see it in my head. It had white markings on it.
Well, yeah, it's a tantalum, right? So
Yeah.
it's usually orange or whatever.
This
but
one was black.
It's black, and
Yeah.
it's
it was funny. I think
yeah.
I called you about it because I was having problems, and you're like, "Is it black?" I go, "Yeah." How did you know? Right? Because he must have had problems with it before.
Yeah,
Nice. The other thing is we're stacking more stuff on top of each other.
yeah.
So then your 2D top-down X-ray isn't sufficient because you're looking through the two sides of the board. Some assemblies are now sandwiching the board, so you're looking through 4 layers of soldered components.
And you're looking even at like wafer bumps and stuff with
Yeah,
like,
yeah, inside the chip itself.
Yeah,
So for those, you need to do 3D X-ray, and that's where laminography has really stepped up. A lot of improvements from years back. We can do a scan in just a couple minutes, and you're going to have a nice 3D volume that you can now virtually slice through. Look at those solder joints, look at the voiding in them, find cracks, head and pillow, all those kinds of defects. You can really see them very easily in 3D.
I know with through-hole stuff, I mean, every class has a different specification for how much barrel fill is required.
Right.
And I mean, without X-ray, without CT, you can't actually say how much is inside that barrel. I mean, if you're getting perfect topside fillets on the other, if it's making it all the way to the destination side, then you're okay. But or likely, I guess, you can still have some problems in there. But that verification, I mean, you go from trying to just trust your process and hope it works to, if you put through a scan like that, you're going to know for sure exactly where you're at.
Exactly.
Yeah.
And that becomes incredibly critical on RMAs and whatnot, right?
Sure.
You build 2,000 boards for your customer, you get 1 or 2 back. Well, they don't work. What happened?
Yeah.
You want to take a deeper dive into it and see what's going on. Getting that 3D reconstruction of the different areas is invaluable.
And I don't know what it is, probably the simple guy in me, but I just love looking at a 3D image and being able to spin it around and zoom in and out.
Absolutely.
It's just cool.
It is
it's
really
just cool.
cool.
And then to be able to slice layers too, right?
Yeah.
It's just a whole, it's like taking your eyeballs and making it superhero-y almost, you know? It's sweet.
So this part isn't actually just to give Sean a hard time, but when we were actually there and we got to see you load a part into the X-ray and run the scan. I mean, how long did that take? What?
We just did a couple minutes,
right?
Yeah, it was fast.
probably less
And
than 5.
I could not believe the clarity and
Yeah.
the level of detail. And if you would have taken that and done a really deep scan on
Right.
it, what's the resolution or what's the level? Is it single micron?
Yeah, I mean, it depends what you're doing, how close you can get it to the tube. So like a silicon wafer that's just super thin, we can get like 0.65 microns on. But on a board, you're thicker. So single-digit microns easily voxel size. I mean, just incredible resolution you can see.
And I remember when we had you on, you were talking about there's a need outside of just EMS, right? For X-ray. I think you were talking about glass, right? Wasn't there something about glass? There was some type of substrate you were talking about that.
Oh, yeah, the glass.
Because that's what was there the first
right.
time I went to his facility. That's what they were showing me was these scans of.
Yes.
They had done like laser drilling through glass.
Yeah.
And
They're actually here at the show. Right over
BKF,
there.
right?
Yep.
Yeah.
So that traditionally chips have been made with silicon, and then they make substrate material, and they've been largely using silicon still. But there's a transition to try out glass because we're making just like incredible glass that's largely been used for flat panel TVs, and so. As an industry, we got very good at making these really precise, large sheets of square glass. And so there's work being done to make chips that are going to depend on that, but you need to drill into it. So TGVs are through glass vias, and then they metalize them, very similar to a board.
they plate them, essentially.
Yeah, pretty much. So it's pretty amazing. And they're... Yeah, we're talking like 10 microns wide, these holes. I mean, they're tiny little things.
That's crazy.
It's really incredible.
Yeah,
It's
weird
so
shape,
small.
too.
Yeah.
The way the beam goes through it, the shape it leaves.
It's conical almost.
Yeah, it was.
Yeah.
Yeah, it's like an hourglass shape.
Yeah, I think it's really interesting to look at some of the other applications for industrial X-rays. Like, I don't know if I can say this, but you had like a pallet of bricks when we were there.
Yeah.
And you were X-raying these bricks, and I was like, why?
Yeah. That was my question when I came in. I was like, what are you doing with a pallet of bricks? Why would you X-ray that? Right? Because X-ray is not the cheapest way to look at stuff, right? And so it's typically reserved for your higher reliability type things, your medical devices. Anything that goes into space, they're definitely making sure it works, right? But a brick, it's like, come on.
It's going to be one hell of a retaining wall.
Yeah. Well, apparently they're for furnaces, like an oven, for
kiln almost.
A kiln. So they're going to crazy high temperatures. And if you have a nail in the middle of that, it's going to melt. It's going to create a little void inside of it, potentially explode or crack. And now you've stacked all these bricks up into this huge thing,
and you
that
got a
one
failure
there needs
somewhere.
to come out.
Wow.
And you're like, well, let's take everything above it off.
Right.
That's worth X-raying it and
Wow.
just making sure, right? So yeah, the stuff we get a X-ray is pretty awesome, and not just us. I mean, X-ray in general is pretty awesome. What it's being used for. We had a guy come by. It's like, oh, Common Exelon. Yeah, we used to buy your generators to X-ray chicken for bones, like chicken meat
And food
like in their
processing.
meat. Yeah, food processing. I mean, I had heard a long time that any packaged food has been X-rayed to check for
Really?
metal and just contamination
I didn't know that.
of those like debris, right?
It makes sense when you think about it, but I think,
I don't know if I want my
X-rays
food shot with
probably more-
X-rays.
well,
That's
you go to
fine.
the
It's not
dentist,
gonna-
they shoot you with an X-ray, so
No, I got the special one.
Oh, boy.
allegedly. But yeah, I think X-ray has a lot of practical applications in our space and beyond.
Yeah.
And then, like Sean was alluding, it's also just super gratifying to
It's
look
so
at.
cool.
Yeah, it's
It's
a lot
so
of fun.
cool.
I know. Whenever we've been there, I just always talk to your applications people, and it's just like, man, you just get to play around all day.
Yeah,
Because
that's what they do.
Yeah, because
They
they,
just have
take
fun.
these scans and then they're figuring out what's the best way to model this information, display it, and bring out the different characteristics and the
Yeah.
definite. It's pretty
Some
interesting to
people
watch.
have all
them.
the fun, huh?
I do.
Right.
Fortunately, every time I go there, I bring whatever electronics broke, and
Yeah.
just like, let's scan this and see what happened.
Yeah.
Like your toothbrush.
Yeah, the
Yeah.
toothbrush that broke. My wife had like one of those little earbuds.
Yeah.
My dog got it,
Yeah.
and I was like, hey, there's a tiny battery in here. Let's X-ray it.
Yeah.
I know why it broke, and I can't fix it, but let's take a look inside.
Yeah. Seeing that technology is cool.
Yeah,
Like that
it's amazing
inside look.
what we're building and designing, and it's great.
Well,
Well-
David, it's always fun to talk to you. You've
Yeah.
become a good friend of ours, and
Yeah.
you're, like I said in the beginning, you're our X-ray guy, and I know that we've all hit you up at various times for questions or expert advice.
Always
So,
happy to help.
yeah, thanks for being on with us, and I hope
Definitely.
it's a great show for you.
Yeah, thanks for having me on.